Recitation problem 3. A solid cylinder of mass equal to 10 kilograms and radius of 0.25 meters, its moment of inertia is equal to 1/2 mr squared, is rolling and its translational speed is equal to 5.0 meters per second. It encounters an incline that makes an angle theta with the horizontal. What is the maximum height that can be reached by the rolling cylinder? The first step, as usual, is to sketch the different forces acting on the object. In other words, sketch a free body diagram. The cylinder is under three forces: the normal force, which is perpendicular to the surface of contact, the weight mg, which is acting straight down, and finally the static friction force, which is acting down the inclined plane and parallel to the surface. Notice that the only conservative force is the weight mg. The normal force is a non-conservative force, and it does zero work because it is always perpendicular to the surface of contact, therefore perpendicular to the displacement of the cylinder. Writing down on the side, the work done by the normal force is equal to 0. The static friction force always does zero work, as stated in the lecture video. Therefore, the work done by the non-conservative forces, which are the normal force and the friction force, equal to 0. Because the work done by the non-conservative force is equal to 0, the mechanical energy of the system, which is the cylinder, must be conserved. The kinetic energy initial of the cylinder plus the potential energy initial of the cylinder equals the Ke final plus the Pe final. Notice that the kinetic energy for rolling objects come in two different forms, translational and rotational. The kinetic energy initial is equal to 1/2 mv initial squared plus 1/2 I omega initial squared. The potential energy comes in one form only, which is the gravitational potential mgh initial, equals the kinetic final, which is 1/2 mv final squared plus the rotational part, which is 1/2 I omega final squared plus the gravitational potential mgh final. Notice that the cylinder comes to a perfect rest at some point, therefore the final kinetic energy is going to be 0. Now if we choose the bottom of the incline to be the reference point of measurement of heights, which means that the height initial equals to 0, therefore the mgh initial is also going to equal 0. Now we are ready to detail this equation a little further. The translational kinetic energy is 1/2 mv initial squared, leave that one alone. The rotational kinetic energy can be written down as follows: 1/2. The moment of inertia for the cylinder is equal to 1/2 mr squared times the angular velocity squared initial, which can be converted to linear speed. Omega equals v initial over r. Therefore, when you square it, it becomes v initial squared over r squared. That is going to equal mgh final. Notice that the r squared are going to cancel out from the left hand side. Notice also that the mass is a common factor, therefore is going to cancel out. Therefore the equation is now simplified to 1/2 v initial squared plus 1/4 v initial squared equals gh final. The common denominator between the half and the quarter is 4. Therefore, the left-hand side is going to equal 3/4 V initial squared. That is going to equal GH final. Isolating the height final, we obtain 3/4 V initial squared over G. Solving numerically for the height final, we obtain 1.91 meters.